Hello and welcome to another video. In this video we're going to be working on middle of a linked list. And in the problem you're given a head of a linked list and you want to return the middle. So if there's two middle nodes, return the second one. So here there's two middle nodes, so return the second one. And so there's kind of two ways you can do this problem. One is you can get the length just by traversing from the start to the end. So you can start here, just keep traversing down, get the length. And then you can just divide by 2. So in this case we'd get 5, divide by 2. We want to floor divide and get 2. And then we just move up that much from the start. So then we'd start here, we'd move up 2 nodes, we'd get this. Then in this even example, you would get 6, divide by 2, and get 3. Move up 3 nodes from the start, so 1, 2, 3, and that you get that. Basically, whenever you want to try this middle of a linked list, you want to try it for an odd and even list, and if it works for both, then it'll work for any size. So you just try it for some medium-sized linked list, 3 nodes or 4 nodes or something. It's going to be good enough. The other way to do it is a fast and a slow node. And this is also something you want to try for 2 linked lists. So you want to try it for an even and odd. So let's try even first. Let's just say we'll have 4 nodes. Or we can have 6, I guess. Doesn't really matter. So we can use, usually you want to use 4 and 6. Or not 4 and 6, 4 or 6. And 3, or probably 5 is pretty good for the other one, for the odd. So let's say we have 6. Here's our linked list. So essentially, you kind of want to experiment and figure out what exactly your values need to be for this to work. So here we'll have the fast pointer, and we'll also have the slow pointer. So the blue will be the fast, the brown will be the slow. And we need to figure out exactly what we need it to be. So if our blue is the fast, so let's just see how this will work, if this will line up where it needs to be. So this brown needs to end up over here, and then we can figure out what criteria we need for that. So if this moves up 2 and this moves up 1, whoops. Then again, so you can see the brown needs to move up 1 more, we need this node right here. So in order to do that, we need to keep moving up the fast pointer as long as it has a next node, which it does here, right? So it has a next node, so we'll move it up again, it'll be out of bounds, and then our brown will be right where we want it to be. So as long as our fast pointer has a next node, we can move it up, and it's fine to be out of bounds. Now let's try the odd, and so let's see if that holds up. And if that holds up for those two, it'll hold up for anything. So as long as their fast pointer has a next node, which it does, so let's move it up. 1, yeah, I think their fast was the blue. And slow is over here. Then our fast will come over here and here. So you can see the fast doesn't have a next node. So you want to make sure that the fast has a next node, but then it might not have the node after that. So this node has to exist, but then the one after just might not have to. So you don't want to go until your fast node goes out of bounds, because if you go until your fast node goes out of bounds in this example, then you will end up in the wrong spot. So you'll end up over here. And so that's the idea. So as long as our fast has a next node, we'll just move them both up. The fast will go up 2, the slow will go up 1. Try this for an odd and even, figure out exactly what values you need, and then return that way. Or you could do the length if that makes sense to you as well. This one's just a little bit more tricky. So we can code both approaches just because it is an easy problem. So the first approach, we're going to get the length. So we'll just say length equals 0. And we'll have a current node equal to the head. So we'll say while current node is non-empty, add to the length and move it up. Then when we get the length, we can divide it by 2. And we make the current node equal to the head and move it up length amount. So we'll say for I in range length, let's move up our current node. And finally return the node. So hopefully I didn't script the math there. This needs to be head, too many 1 letters. So let's see. Okay, so that one works, right? Where we just literally get the length. Now let's try the other approach. Let's comment out this one with the fast and the slow. So we'll say slow, fast. They both start at the head. So then we'll say while fast.next. Remember, we can move them both up as long as the fast pointer has a next node. We'll say slow equals slow.next and fast equals fast.next.next. And we shouldn't have a null pointer because we're always checking for a fast.next. So if fast.next is null, that's fine, but we're never going to have we're never going to check for the next node of a null pointer. Then finally, we just return slow. So we do have an error. Let's see what the error is. None type. Oh, right. We do have to check if fast exists, though. So this one we do have to check for, because fast might be null already. So there we go. And as far as runtime, I wouldn't be super concerned about which one's better. As you can see, like almost all the runtimes are pretty close, so it doesn't really matter. So these are both time of. So essentially, you're basically doing a 2-pass either way, even though for the slow and fast, they're moving kind of at the same time. You're basically doing a 2-pass either way, and it's of and space is of1. So both solutions work. Definitely be comfortable with both, and basically be comfortable with this because you're gonna have to know how to do this and then split the linked list down the middle and then do something with like the other half or something. So definitely want to know how to get to the middle, the node before the middle, the node after the middle, all these kinds of things using one of these two strategies. But yeah, that's gonna be all for this one. So if you like this one, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.